Hello again. We are looking at example number 2 from your pre-calculus textbook. This is under lesson 1-5 on page 194. This time we're going to, previously on one of the videos I showed example 1, which was how to write an equation that is parallel to a given line. Now we're going to write an equation of a line that's perpendicular to a given line. And there's two parts to this. A, it wants us to find the slope of any line that is perpendicular to the line whose equation is x plus 4y minus 8 equals 0. Now this is called standard form when it looks like this. And then the B part wants us to come along and say to write a specific equation of a line that's passing specifically through 3, -5 and is perpendicular to that same line. Okay, so the first thing we're going to do for A is we're going to begin writing the equation of that in slope-intercept form. That means we're going to solve for y. And so mathematically, let me go over to the top of the next page. As we go through the process of getting the y by itself, we end up with y equals -1/4 x plus 2. Now, when it's in this form, this means that this -1/4 is my slope. Okay? So the given line has a slope of -1/4. Now, any line that's perpendicular to that slope right there will always have the negative reciprocal. Sometimes I say opposite reciprocal. So if that's -1/4, you're going to go opposite of negative, which is going to be positive, and then you're going to flip 1/4 to make it 4/1. Thus, the slope of the perpendicular line is going to be 4. You can leave it over 1 if you like, but the answer is simply just 4. That is the opposite or negative reciprocal of that, because that's what happens when two lines are perpendicular. Their slopes are not only negative of each other or opposite of each other, but they're the reciprocal of each other. Now, if we're going to find a specific line that goes specifically through the point 3, -5, again, anytime you're given a point, and of course we just figured out what the new slope is going to be. If you know the slope and you know a point, you're going to use point slope form again. So it's y minus, and you're going to plug in the -5 from your y value here, equals slope. Notice we're going to plug in the 4 that we found, and then x minus, and the x1 here is found by plugging in the 3, which comes from right there. Okay, now, as we distribute, as you can see right here, first of all, a minus is going to become plus 5. Distribute that 4 to the x and the 3. You're going to get 4x minus 12. Okay. You're going to get y plus 5 equals 4x minus 12. You're going to subtract the 5 over to this side, because what you do to one side, of course, you always have to do to the other. And so what you're going to end up with really is you end up with y equals 4x minus 17. Now that would be slope-intercept form, okay, when you do it that way. However, this time it wanted us to put it back into general form. General form means everything is on one side and the other side is equal to 0. So that's why you see them subtracting the y over and the 5, both here and here. It cancels everything over here, of course, to give us our 0, and then we end up with 4x minus y, and then, of course, the minus 17. Okay, so this is really the same thing as this. It's just put in what's called general form, because that's what the equation, for some reason, asks for. I would much prefer slope-intercept form, because it's much easier in this form to graph it and to do things with it. But because it asks for general form, that's why they ended up putting it in this form right here. Okay? Hope that was helpful.